Hi, this is Aparna Haryani from University of Florida, and I am here to present my project on emotion recognition using face detection. So, let's start with why do we need face recognition and why is this project so important? Uh, in these days, facial recognition, emotion recognition is a very booming technology. It has a very high demand in the field of robotics and machine learning, such as we use emotion recognition in places such as psychology, and psychiatrists use it to test whether the patients are honestly answering the questions, or are they lying, or are they under stress. Even detectives use it as lie detectors, and so on. In the field of emotion recognition, classifiers and feature extractors play major role. So as I earlier mentioned that there are a lot of applications of emotion recognition. A few of them I mentioned. One of a very recent and important application is in website and UI testing. So supposedly we build a website, we give it to someone for testing. So we can access the person's facial features using the webcam while he is using the website, which would give us a precise data, as in how comfortable he is in using the website. Like if the website is easily accessible, his face would be happy and satisfied. Uh, the expressions would say that it's happy or sad or he's frustrated or whatever. So that is one of the major applications which is being used these days. And as I mentioned earlier, it's been used by investigating departments and psychological and research therapy and so on. So it all depends on how accurately the algorithm is able to recognize the emotion, and efforts are being made to make it more and more efficient. One of the advantages using emotion recognition by machine over human would be that the machine wouldn't be biased such as humans. Like human would question their judgment, saying that this might be because this was the situation and so on. But machines don't have that ability of thinking. They would do as we train them. So if we train them efficiently and accurately, the emotion recognition would be more accurate. So let's start with existing approaches. There are various classifiers used these days to classify and predict emotion recognition and train the algorithms. So, one of the major classifiers used is k nearest neighbor. Uh, the image here shows the k nearest neighbor and how it works. Supposedly, the green star is the star which we need to classify, and the blue and red stars have already boxes have already been classified as class A and class B. So, uh, there we can set a variable k to a certain amount like 3 or 5 or 6 or whatever, and belonging uh, and then within that range there is a circle drawn of a radius of 3 or 6 or whatever we say, and the data that between within that circle, whichever class data is maximum, the green star belongs to that class. So this is how k nearest neighbor works. Har cascade works on uh, edge features, line features, and for rectangle features extraction method. It uses positive and negative images to classify the data. So, for example, for face recognition, we would provide the classifier with images that would have faces. That would be positive images, whereas we would provide the classifier with data of images which wouldn't have faces, that would be negative images. And using that, the Har cascade classifier is trained and then is used for further usage. The landmark based classifier, as shown in this figure, there are 68 points on the face that are landmarked. It includes the jawline, the mouth area, nose, eyes, and eyebrows. So, based on each and every expression, these major features change. Like supposedly, if someone is surprised, the mouth would be open, the jawline would be extended, eyebrows would be raised, eyes would be widened. uh, so this is one of the example how the landmass place classifier will be used, and which we have used for our classification method. Support vector machine, as shown in this diagram, support vector machine is somewhat similar to k nearest neighbor, but it does not have mixed data set, whereas such as there is a linear line, or there is a distinguished area where certain classes of data would reside. So this section here shows class A data, whereas this section here shows class B data, and depending on where the new unknown class uh, is there, the line varies. Suppose it this blue class, so I'm sorry, this blue class, as we see this, suppose this is unknown, so the data would the line would then be like this instead of being just a straight line here. So these are the classifiers used, and we would be using Har cascade and landmark based detection classifiers for our approaches. So my program algorithm is divided into two stages. What in stage one, I'll be downloading the Kannada extended data set and sorting it using Har cascade into various emotion categories of anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. The Kannada dataset has 593 images and 123 subjects. This is an acted dataset, so the pictures are not naturally taken, and the emotions won't be natural. But the subjects have done their best to uh, portray the given emotion effectively. In stage 2, I will shuffle the data set, the sorted data set randomly, and then use the 80% of the sorted data set to train the classifier, and 20% of it to test the classifier. Uh, then, using the DLibs frontal face recognition to detect the faces in images using the file shape predictor, which helps us classify the landmark on the face detected, and using those landmarks, uh, we train the classifier to detect whether the landmark we train the classifier to detect whether the landmarks suit which expression, and hence we classify the emotion accordingly. We repeat these shuffling and the entire process, like training and testing the classifier 10 times, so as to calculate the average accuracy of the algorithm. Let's start with demonstration now. And these are the Python files that I am using. Organize1.py helps us sort the dataset uh, into various categories of anger, contempt, disgust, fear, happiness, neutral, sadness, surprise. And facedetect.py helps us detect the faces in these datasets, and using Har cascade. Emotiondetection.py is the file which uses the landmark based detection and dlib libraries to train and predict uh, the data from the dataset, and it uses shape predictor 68 face landmarks dot dat file. So sorting the set takes quite a bit while, so I have already done that, and running I would be running the detection.py file now. This will take a while to. Meanwhile, I'll explain you guys how this algorithm and landmark based technique works. Uh, so so using this image, I can explain you very better how this things works. These are all the landmarks, 68 landmarks as I mentioned earlier. We consider this 30 tip of the nose as the center of gravity, and using that as a reference, their lines are drawn to each of the landmark points, and each line has its magnitude and angle. So depending on expressions, these angle and magnitudes change, such as if the eyebrows are raised, the magnitude of lines 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 would change, like the magnitude would increase as compared to the standard magnitude. Each person, these magnitudes might vary from person to person, but for a person it wouldn't vary, they would just vary for expressions. We also have fixed this algorithm uh, so that if uh, there is an image which has tilted faces, uh, the classifier would try to recognize it correctly. We try we take the center of gravity and the angle of nose to predict whether the face is correctly uh, whether the face is perpendicular or at an angle, and the distance between the perpendicular line drawn from the center of gravity and the angle of the nose, we we get an angle beta to which the face is tilted, and accordingly the class all the landmarks are tilted, and hence we can classify and predict accurately. So here we see it would take 10 iterations. It's just making sets and training linear SVM, and it will just give us accuracy of each run, and this will run 10 times, so we'll have to wait up till it runs 10 times.